Good morning. This is Unit 6, Day 4 notes. So we're going to go over expectation and then variance today. If there are n number of trials, so n are the number of trials, and an event has probability p of occurring in each of the trials, then the number of trials we expect the event to occur is the number we expect it to occur is the number of trials times the probability. So we're multiplying them. Each time a football player kicks a goal, he has a 3 in 4 chance of being successful. In a particular game, he has 12 kicks for a goal. How many goals would you expect him to kick? So the number x is the number of goals scored. Then the probability or the expectation of x or E of x equals, since there's 12 kicks, and we're going to multiply this by the probability, right, which is 3/4, 3 out of 4. I think this equals 9 goals. We expect 9 goals. Okay. I want you guys to try this one. We have this theorem that says the expected outcome for the random variable x is the mean. So this is going to be our symbol. In general, the expectation of the random variable x is the mean. This is also the summation of, as I goes from 1 to n, of x sub I times the probability sub I, okay? Or the summation as I goes from 1 to n of x sub I times the probability of x equals x sub I. It's pretty much the same thing. Remember that the summation means we're adding them up. So when we plug in 1, it's going to be x sub 1, p sub 1. Plus, when we plug in 2, it's going to be x sub 2 times p sub 2. Plus, we're going to keep going all the way until we get to n, x sub n, p sub n. A magazine store reported the number of magazines purchased by its customers in 1 week. 23% purchased 1 magazine, 38% purchased 2 magazines, 21% purchased 3, and 13% purchased 4, 5% purchased 5. Find the mean of the data or the expected value. So the mean or the expected value is 1 magazine times the 0.23% of them plus 2 magazines times the 0.38. Maybe remember that we turned this into a decimal, not a percentage, so we turned it into a decimal, plus 3 times 0.21, okay, plus 4 times 0.13, and plus 5, I guess, times 0.05, 5%. When we put this into a calculator, we get something like 2.39 is the mean. 2.39 magazines is the mean. Okay. A random variable x has a probability distribution given by this formula when x is 1, 2, and 3. Show that the probability of x is indeed a probability distribution function. So do they all lie between 0 and 1? Let's find the probability of 1. When we plug 1 in, we get 1 squared plus 1 is 2 over 20, or 1 over 10. When we plug in 2, we get 2 squared, which is 4, plus 2, which is 6 over 20, which is 3 over 10? I don't know. Check it. And then when we plug in 3, substitute in 3, we get 9 plus 3, which is 12 over 20, which is 3 over 5? I don't know. Check it. So all of the probabilities, all p sub i's, all the probabilities lie between 0 and 1. So the summation of p sub I equals, the summation of p sub I is 6, 7, 8, 9 is 1. Great. So this is indeed a probability distribution function. Calculate the mean for this distribution. Well, the mean is the sum of, remember, x sub I, p sub I. Okay. Well, it's 1 times the 1 over 10. We plugged in 1. Oops. Plus 2 times the 3 over 10, and plus 3 times the 3 over 5. I think if you plug this into your calculator, you're going to get 2.5. Can you guys pause it and make sure? That'll be your mean for this distribution. So a matter of fairness, in gambling, we say the expected gain of the player from each game is the expected return or payout from the game, less the amount it costs to play. The game will be fair if the expected gain is 0. All right, suppose X represents the gain of a player from each game. The game is fair if the expected gain is 0. Okay, so let's look at this. In a game of chance, a player spins a square spinner labeled 1, 2, 3, 4. The player wins the amount of money shown on the table alongside, depending on which number comes up. Determine the expected return for one spin of the spinner. So X is the return of one spin. On. Okay. So the expected return is 1/4. We have 1/4 of a chance to get a 1. And we have a 1/4 of a chance to get a 2. And we have a 1/4 a chance to get a $5. And we have a 1/4 of a chance to get $8. So this is going to be my expected return. I think if you multiply this out, this is $4. The expected gain of a player if it costs $5 to play each game. It's going to cost you money to play these games. So why is the gain from one spin? Then the expected gain is, well, this is how much you're going to get. But it costs $5 to play. So this is actually -1. Is it fair? Maybe not. Would you recommend it? Let me know. I actually think we need more information for this. So I'm going to say if you roll a 6, that's $10. 4 or 5, that's $4. 1, 2, and 3, that'll give you $1. So if I have a 1 in 6 chance to roll a 10, this is going to be 1 in 6. There's 2 numbers that give me $4, so that would be 2 in 6 or 1 in 3 chance. And there's 3 numbers that'll give me $1, which is actually 1.5. What is your overall expected result for this game? My expected result is $10 times 1 in 6 and $4 times 1 in 3 and $1 times 1/2, which is about $3.50. Now the game costs $4 to play, so is it fair? Find out if that's fair. Go ahead and skip this one. I'll do it on the board if you guys can't figure it out. Let's try number 8. Alright guys, so number 8, this one looked a little confusing. It says, at another charity event, there is money raising game involving a pair of ordinary dice. The game costs $8 to play. When the 2 dice are rolled, their sum is described by the variable x. The organizers decide that the sum, so we're going to add these 2 dice together, which is less than 4 or between 7 and 9 inclusive, so we can include 7 and 9, is a loss of a over 3. A result between 4 and 6 inclusive gives a return of $7, and a result of 10 or more gives a return of $21. That's what it says. It says to determine the probability that our sum is less than or equal to 3. So I made this chart. This is our dice 1 through 6, 1 through 6, and we just added it. So 1 plus 1 is 2, 1 plus 4 is 5, 1 plus 6 is 7. And I kind of color-coded it. What I'm going to do first is find the probability that x is less than or greater than 3. And there are 3 spots where this is less than or equal to 3 out of 36. So 3 out of 36 simplifies to 1 over 12, I think. And let's do the second one. The probability that our sum is between 4 and 6 inclusive. It can include 4 and 6. So I'm going to use green. So 4, 5, 6, 4, 5, 6. And I think altogether that is 12 out of 36, which simplifies to 1/3. My probability that it is in between 7, the sum is in between 7 and 9 inclusive. And I made them all red. So this is 15 ways to make that out of 36. And this simplifies to 5 over 12. And we have one more. We're going to see the probability that the sum is greater than 10. So the probability that the sum is greater than or equal to 10. And I made these black. So 1, 2, 3, 4, 5, 6 over 36, which simplifies to 1 over 6. Now for the second part, it says, show that the expected gain of the player is this. This is what we want our answer to be. Let's look at the gain, or how much the loss is going to be. So it says the organizer decided that the sum, which is less than 4 or between 7 and 9 inclusive, has a loss of a over 3. So this one has a loss of a over 3. This is less than 4, a over 3. and between 7 and 9. So this one has a loss of a over 3. And it says a result between 4 and 6 gives a return of $7. So this one is $7. And a result of 10 or more gives a return of 21. So 10 or more is 21. This one is 21. And we're going to use our formula where we're saying y is the gain. So my expected gain is the ones with a over 3 are 1/2 and 5 over 12. If we add these together, this gives me 6 over 12. Or sorry, 1 over 12 and 5 over 12. So this is 6 over 12, or 1/2 times my a over 3 plus 7 times 1/3, or 1/3 times $7 plus, and then we have 1/6 times $21. And then we are going to have to subtract a. A is how much it costs to play. So minus a. I'm going to simplify this. I know that this is a over 6. This is minus. This is a loss, so minus a over 3. So this is negative a over 6 plus, I can put 7 over 3 if I want a common denominator. That would be 14 over 6 plus 21 over 6 and then minus a. Or we can make this a common denominator also and put minus 6a over 6. I'm just going to put minus a. We're going to simplify this, combine the ones with the a's, and we're going to get minus 7 over 6, 7a over 6, plus 35 over 6. Oops. 35 over 6. Now, they want us to make it look like this. All you have to do is pull out that 1/6. So 1/6, 35 minus 7a dollars. There you go. Remember, if we want it to be fair, then we need it to be equal to 0. So my expected value needs to be equal to 0, but my expected value is equal to 1/6 35 minus 7a. I'm going to multiply each side by 6, get rid of that 1/6, and we have 0 equals 35 minus 7a. Subtract 35, divide by 7, a equals 5. Explain why organizers would not let a be equal to 4. I want you guys to try this. Why would they not want it to be equal to 4? So this is another part of this section. We're going to go over variance and standard deviation. So it says if a discrete random variable has these possible values, these are my outcomes, with these probability of occurring, then the mean or the expected value, remember this is the sum of x sub I times the probability sub I, is the population mean or the expectation. It's kind of redundant, expectation of this random variable. The formula for the variance is going to be the square root of the sum of x sub I minus the mean, which is like this, squared, and then times the probability sub I. This is called the standard deviation. An easier way to calculate the standard deviation is the square root of the summation of x sub I squared p sub I minus your mean squared. This is supposedly easier. The variance, which is a standard deviation squared, is just the summation. We square the other side also, so we get rid of that square root. The summation of x sub I squared p sub I minus the mean squared, right? Just this without the square root. It is the population variance. This is called the variance. Alrighty. It says when rolling a standard six-sided die, what is the mean, variance, and standard deviation? So in order to do this, first we need to find the mean. I just drew a table and I wrote in there the dice and then the probability of each side, of rolling each side. So the mean is a sum of the expected times the probability of each. So this is going to be, to get a 1, it's going to be 1/6. Plus to get a 2, this is 1/6, 3, 1/6, 4, 1/6, 5, 1/6, and 6. We have a 1/6 chance to get either side. Now when we multiply these out, we're going to get 3.5. This is our mean. To get our variance, this is going to be, remember, the summation of x sub I squared p sub I minus the mean that we just found out. So we need the mean in order to do this, squared, which is equal to 1, no, not yellow, 1 squared times 1/6 plus 2 squared times 1/6. I'm going to keep going. 4 squared times 1/6. 5 squared times 1/6. Oops. 6 squared times 1/6. Now we're going to also have to subtract my mean, which is 3.5 squared. So square it. And when we plug this into the calculator, my variance is 2.916666, and it's going to keep on going. So 2.916 forever. Now, if we want to find the standard deviation, which is just the square root of that, take the square root, and that to the square root of 2.916, and that equals 1.71, about. Alright guys, I want you to try the rest and let me know if you guys have any questions. Have a wonderful day.